Okay, in lesson 34, we're going to talk about summation notation. A big pointy looking thing there is called a sigma. It's the capital letter sigma, Greek letter. And it means, in math, it means sum. So sum means adding. And so what this is telling us, what it means is as we go from y equals 1 up to y equals 4, we're going to add this term, y squared. So if we start at y equals 1, that's where we're supposed to start. So when y equals 1, what is our term? This is our term that we're going to be adding. It is 1 squared because it's y squared, so it's 1 squared. Now we add because this is adding. This is a sum. We're going to go on up to y equals 2 next. When y equals 2, our term is 2 squared. Now we're going to go up to y equals 3. When y equals 3, our term is 3 squared. And now we'll go up to y equals 4, which is where we're going to stop. And when y equals 4, our term is 4 squared. So the summation just tells you as y goes from 1 up to 4, one at a time, you're going to add this thing, y squared. All right, so that's going to be 1 plus 4 plus 9 plus 16, which is 30. So that's what this equals. It equals 30. Summation as y goes from 1 to 4 of y squared is 30. Okay, so now we have another one, and this one is the sum as j goes from 0 to 3 of this term, 2 to the j over j plus 1. So we're going to start at j equals 0. That's where we're supposed to start, at the bottom number. So what's our term? When j is 0, our term is 2 to the 0 power over 0 plus 1. Now we're going to add the next term. We'll go up to j equals 1. When j equals 1, our term is 2 to the 1 over 1 plus 1. Now we're going to go up to the next term. J equals 2. When j equals 2, our term is 2 to the second over 2 plus 1. Now we'll go up to the next term and our last term. J equals 3, adding 2 to the third over 3 plus 1. So we're going to add those 4 terms up. So even though it goes from 0 to 3, it looks like we should only have 3 terms. But in this one, we actually have 4 terms because we're starting at 0. The one before, we started at 1. So you have to pay attention where you're starting and where you're finishing. All right, so I'm just going to erase all these little j's here. All right, so we're going to add it up. We've got 1 over 1 plus 2 over 2 plus 4 over 3 plus 8 over 4. So that is 1 plus 1 plus 4 thirds plus 2. So 2 plus 2 is 4 plus 4 thirds. And that's going to be 12 thirds plus 4 thirds is going to be 16 thirds. And that is what that sum adds up to. Now we have the sum as I goes from 1 to 5 of the term 3. All right, so we're going to start at 1, I equals 1. When I equals 1, what does our term equal? Well, it equals 3 because there's just a 3 there. There's no I involved. So it's 3. All right, now we go up to the next thing. We're going to add I equals 2. Well, when I equals 2, the term is still 3. So we'll add a 3. Now we're going to go up to I equals 3. When I equals 3, the term is still 3. It doesn't change. Now we're going to go up to the next iteration. I equals 4. Term is still 3. We'll add another one. And now I equals 5, which is our last one, and that is still 3. So 3 plus 3 plus 3 plus 3 plus 3 is 15. So the summation as I goes from 1 to 5 of 3 is 15. Okay, we're going to talk about function decomposition, but first let's go back and remember about function composition. when you have the composition of two functions, or f circle g of x, you are combining these two functions in a way, one of the functions, you're going to put the other function into that function. So, for example, here we've got f of x equals 2x plus 3, and g of x equals 1 over x. F circle g of x is going to be f of g of x. So you're taking the function f, 2x plus 3, and you're putting the function g into that. So wherever you see an x in the first function, you are going to put the function g of x, which is 1 over x. So that becomes 2 times 1 over x plus 3. It's a new function called f of g of x, or f circle g of x. It's a composition of two functions. Now, what does the new function do? Well, if you put a number in there, x, first of all, it takes the reciprocal, then it multiplies it by 2, and it adds 3. Those are the things that happen to the member of the domain when you put it into this function. It does two things, right? Well, let's look at the initial two functions. The first function would multiply a number by 2 and then add 3 to that. The second function takes the reciprocal of a number. So the new function does both of those things. It takes the reciprocal of a number and then multiplies it by 2 and adds 3. So what we're going to be doing now is we're going to be looking at a function that's already composed like this, starting with this function. Say, well, what could the two functions be that made that composition? All right, so find two functions, f and g, such that f circle g of x is equal to the square root of x squared plus 1. Well, we're going to look at the two things that happen here. We have a function that takes the square root of something, and then we have another function that squares a thing and adds 1 to it. So those could be our two functions. F could be the function, f of x, that takes the square root of something. It takes the square root of whatever number you put in. So f of x could be the square root of x. The other function, g of x, could be the function where you take a number that you put into the function x, square it, and add 1. So will this work? Do I have them in the right order? Let's see. F circle g of x is f of g of x. So this would mean you take the f function, taking the square root of something, and you put the g function into it. And the g function is x squared plus 1. So function decomposition is not, there's not necessarily only one answer to the problem. So you have to, there's some trial and error involved, but the thing to do is just look at this function you have. That's a combination of a couple of different things, and then write the functions that do those two different things or three different things, and see how you can arrange it so that you'll just have two functions where you put one into the other one, and it makes that work. We have g of x is x squared plus 1, and f circle g of x is equal to 1 over x squared plus 1. So now they've given us one of the functions, and they've given us the composition. So we have to find f, the other function. So g of x is this, and we're putting g of x into f of x. So we're taking this number, whatever this is, and we want it so that this happens to it. So f is going to be the function that takes the reciprocal of something. So that's what's happening here. You've got g of x as x squared plus 1. The composition is supposed to be 1 over x squared plus 1. So if you want to make that happen, you need to make f the function that takes the reciprocal, because you're putting g into that function. So just to show you, f of g of x, that's going to be f of g of x is x squared plus 1. So that's what you're putting into the f function where you see an x. So that is 1 over x squared plus 1.